So we come to the second speaker, none other than Dr. MRA Pillai. I have the honor and the pleasure in introducing Dr. MRA Pillai. He needs no separate introduction. Nonetheless, I will read out a few of his salient achievements. So at present, he is a group director of Molecular Group Cochin. He has a total experience of 50 years almost in this field. His areas of interest is radiopharmaceutical chemistry. Few of his major achievements include, he worked at the Bhabha Atomic Research Center, University of Missouri, Columbia, and the International Atomic Energy Agency. He is the associate editor of many prestigious journals like the Cancer Biotherapy and Radiopharmaceuticals. He is the editorial board member of 4 other international journals, including EJNM, MI, Radiopharmacy, and Chemistry. He has got many awards and publications. The ones which are listed here are, he is the founder fellow of the Indian College of Nuclear Medicine. He is a Homi Bhabha Oration Awardee. He had a Distinguished Service Award and 5 other awards from the IAEA. He's got a Lifetime Achievement Award from A&M PI and IANCUS, Atmanirbharta Award from ISAS, the R.G. Deshpande Award from NARI. He's an avid publisher, and his Google Scholar shows that he has got 310 publications with more than 6,500 citations and H index of 42. And the ResearchGate views are more than 135,000. So over and above everything, I would like to include that he's an excellent mentor, and I had the privilege to join with him when I joined Bhabha Atomic Research Center and work with him for almost 20 years. So it's my privilege, and I request Dr. Pillai to take over.
Thank you, Sharmila, for that very kind and nice introduction. I am not an expert in actinium chemistry, and my whole experience is that we tried to do an actinium PSMA, and after doing that radiopharmaceutical, towards the evening, I was wondering whether I did everything rightly. Because there are a lot of intricacies in actinium therapy. Of course, there are very good clinical outcomes. But before that clinical outcomes, there are a lot of intricacies in application of actinium-225 therapy. One of that is, are we doing everything right as a radiochemist? Now, the good radiopharmacy practices, it mandates that the radiochemical purity of what you are injecting should be known to you. The second is that the amount of radioactivity injected to the patient need to be known. Now, are we able to do that in the case of actinium-225? In the evening when I was sitting after the injection of the patient, I was wondering, did I know the radiochemical purity rightly? Did I know how much activity has gone to the patient? And my answer was no. Now, in the case of lutetium radiopharmaceuticals or any other radiopharmaceuticals, what we do is that we make the complex, and we do a chromatography, and we can separate the free from the radiopharmaceutical. Either the free can go to the top, or the labeled compound can go to the top, depending upon how we are going to design or develop our quality control methods. And it is very simple. You cut the tube, cut the TLC sheet or the chromatography sheet or the HPLC, you will get absolutely good patterns, because there is a very beautiful gamma emission coming out of lutetium which can be monitored. Now, the quantification of the activity also is very simple, because there is a button where you press lutetium. So I know that we have got 280 millicurie of lutetium from Taranjit, and after my complexation purification, I got about 225. And what I am giving to the nuclear medicine doctor, I am perfectly fine. I know what is going to the patient. Now, what is the problem with actinium? You know, I have put in my slide, they have asked me what is the total years of experience. I put half a century. Now, with that half a century of experience, I was still confused when I was doing actinium therapy or involved in actinium therapy. This is because, we asked for actinium-225, but we are blessed with another 7 isotopes. Because actinium-225 has got a half-life of 9.92 days. When it is purified actinium-225 is there, it is decaying to francium, it is decaying to astatine-211, bismuth-213, a part of that goes to thallium, which is decaying to lead-209 by beta emission, and 97% goes here. And this we can consider it as inactive, which is it's a very long-lived isotope. So it is like, you are asking for one isotope, and another 6 isotope is coming free to your center. And this is not the case with lutetium. So when we are going to do the chromatography, or when you are going to do the quantification, we should know what are the qualities of this isotope. In a chromatographic estimation or in an HPLC, what do we measure? We measure the gamma radiation. Now if you look at it, where is the gamma radiation coming from? Actinium has got a gamma of 100 keV. It's a low energy gamma. It is only 1%. And how much activity we bring it? 250 microcurie. And out of that, how much we take it for doing the paper chromatography or TLC? Maybe 10,000 becquerels. Out of that 1% means it is nothing. So we have another the isotope which is coming. It is francium-221. 221. It has got a gamma of 218 keV. The percentage is good, 11.4%. And we also has got bismuth, which has got a gamma energy of 440, and that is 25%. That means at the end of making the radiopharmaceutical, and if you do a quality control, if you do a chromatography, and what you are measuring is not actinium-225, you are measuring is something else other than actinium-225. Let us look at it. I do a radiochemical preparation. I will have radiochemical preparation of actinium dotatate, and francium is present in the same amount of activity. If there is 250 microcurie of actinium, the same amount of francium is there, the same amount of bismuth is there. So we have actually 3 components. Actinium dotatate is there, francium dotatate is there, and bismuth dotatate is there, and we have actually 3 components. And when we do a chromatography, we are not measuring this. What we are measuring is only the 218 keV and the 440 keV. So whatever quality control you do it and tell the nuclear medicine physician, yeah, my quality control or RC purity is 100%. With a chromatography, that is not the right information. Now there has to be means to estimate the quality control. That is what the scientists do. They will always find out a way to measure what is the exact amount of actinium-225. Unfortunately, in a couple of months back, I have seen a paper by Huichman L. et al. Implementing actinium-225 labeled radiopharmaceuticals, practical consideration and preclinical perspectives. A very nice paper published in European Journal of Nuclear Medicine, and I also have taken this as one of the examples and highlighted in a highlight session by all the editorial body members, because European Journal of Nuclear Medicine and Molecular Imaging, as a radiochemistry and radiopharmacy independent journal is there, they allow all the editors to select one paper and put it as a highlight. And I have selected this paper and put it as a highlight. And please, this is little radiochemistry is needed to be known to understand this. And what we do is that we do a TLC or a PC. Then we have 2 fractions. One is actually francium is there and bismuth is there. Of course, actinium is there, but the gammas are so low. When you are putting in a gamma counter, what we are measuring is actually francium, and what we are measuring is bismuth, which is the free. And the radiopharmaceutical is francium dotatate is there, and bismuth dotatate is there. And actinium dotatate is there, but we are not able to see it because the amount of gamma energy coming from this is only 1%. Whatever activity what we are measuring is this. So he has this group has developed a very nice method of how to estimate actinium-225 accurately. Now let us, I have told you there are 3 components. Actinium-225 is there, then francium is there, and bismuth is there. What is happening to these 3 isotopes? We have the actinium, francium dotatate is there. Francium has got a half-life of only 4.9 minutes or 4.5 minutes. By about 30 minutes, all the francium is decayed. And all the bismuth is decayed by about 5 hours. So these are two important things. At 30 minutes, there is no francium which is coming from francium dotatate. And at 4 hours, there is no bismuth which is coming from the bismuth dotated radiopharmaceutical. So at these time points, if you measure it, definitely what you are measuring is actinium-225. But is it that simple? It is not that simple, because there is something which is called a secular equilibrium. If you have a long-lived radioisotope, the long-lived radioisotope, it will keep on decaying in a very small fraction. But if you keep a purified radionuclide like that, the daughter will start growing. The daughter of francium is growing like this. By 30 minutes, the amount of actinium is same as that of francium. Francium activity, if you estimate, it is the same as that of actinium activity. Bismuth also is increasing at 4 hours. That is also coming to the saturation. Now looking at the whole picture, we have something is decaying, something is growing. So what we are going to do is that we are allowing the francium dotatate to completely decay. It will decay like this. And the bismuth dotatate also is decaying. So at this point, there is only actinium present. Now this francium which is growing out of actinium, at 0 point after our purification, the francium is start growing. At 30 minutes, it comes to the maximum. So if you estimate francium at 30 minutes, this is good enough. But the problem is that if you go for estimation of this, there is bismuth gamma coming from not only the decaying bismuth, also from the growing bismuth. So these two gammas will have to be isolated. Other thing is that at 4 hours, if you look at it, actinium has completely decayed to francium, completely decayed, grown to bismuth. And if you do a measurement at 4 hours, whatever francium you are measuring or whatever actinium, whatever bismuth you are measuring is same as that of actinium. So this is how the delayed technique, what they have said, is can be applied. What you do is that you do the quality control, like all other radiopharmaceutical, leave the paper strip there, and after 4 hours, what you can do is that you can measure this, you can cut and put the tubes, and count this activity, and it can be counted with taking care of both the gamma rays, and you will get the information about the quality control of the things. So now, after 4 hours of francium and bismuth will be present in the same quantity as that of actinium. So what you do is that you don't measure the number of actinium, but we know if you measure francium or if you measure bismuth, that quantity is the same as that of actinium, and count the chromatography strip after 4 hours. And francium has 208 keV gammas, bismuth has got 440 keV. So you can open up the window from 50 to 700 and do the counting. So this is one advantage, because you have very little activity, because you are getting 250 microcurie. Out of that, what you are taking for quality control is very less. So you can do this counting after 4 hours. And the question is, can we wait for 4 hours before injecting the patient? Definitely not. You cannot afford to make a radiopharmaceutical and keep it over there, and a lot of those alpha energies are coming and falling to the radiopharmaceuticals. So this is, ideally this is not good. Then what? At 30 minutes, francium originally present decays completely. So what you can do is that you can do a discriminatory counting. You only count in the window of 150 to 250. So you pick up the bismuth, and from that you can get an information. Probably if you can wait for that 30 minutes and do the chromatography, you are sure about it. So, and we also have to do the backscattering correction for bismuth gammas. For 40 keV will be needed. So this is another intricacy or the complication in radiopharmaceutical, estimation of activity. Has anybody doing actinium therapy, have they estimated how much is the activity which is being injected to the patient? I think, I don't know. My experience is we have not done it. here the problem is that when the activity is coming from abroad, we have all the 7 isotopes, and after purification, we have only actinium-225. And that actinium-225 don't have any gammas unless it grows completely to some francium or bismuth. So by putting in a dose calibrator, you will not be able to measure it. You will not be able to measure any of these actinium-225, what is injected to the patient. Now, assuming how the manufacturer knows how whether I am sending is that 250 microcurie or not, or 500 microcurie, he will do a gamma spectrum. He will do a gamma spectrum, and he knows that this is actinium is what you want to measure. But instead of measuring actinium in secular equilibrium, if you measure francium is good enough. If you measure bismuth is good enough. So having a HBG counter, a multi-channel analyzer with calibrated multi-channel analyzer, you will be able to measure how much is the radioactivity. But are we having a multi-channel analyzer in our center? We don't have it, and we cannot afford it in a radio pharmacy. So this intricacy of the second intricacy, that how much I am going to inject, probably it will remain for some more time. So a radio pharmacy neither have an expertise. This is also it is not like doing lutetium. The radiopharmacy practices are increasing day by day. Earlier, the radiopharmacist only used to take technetium and mix it. Then it came to gallium production. Then it came to lutetium production. And finally, it is going to alpha therapy. So the radiopharmacy practices have to increase commensurate to the amount of work what we are doing it. So the intricacy continues. And the conclusion is that the PCTLC can be done for the purified product, and counted immediately gives an estimate of francium and bismuth and not that of actinium-225. But you can use that as one of the indicator, but not as the absolute. And also, when you are doing the chromatography, if the chromatography takes 10 or 15 minutes, the francium is also growing. So if you do the chromatography counting immediately, you will find that it is a dirty chromatogram. What we want is a clean chromatogram, something remaining at the point of spotting and something remaining at the end. And there is very little option to measure activity. And actinium therapy is in the nascent stage, and we need to learn a lot. It is not like, somebody is giving us actinium-225 and we take the other component, mix it, or pass it through something and inject it. And the radiopharmacy practices has to much improve. So with that, I will conclude my talk. Did I confuse you? I am sure, many of us were complacent, feeling that, yes, we are doing everything rightly. But that was not my feeling after I finished my actinium-225 PSMA preparation. So little amount of confusion still remains. So thank you very much.
So thank you, Dr. Pillai, for sharing your experiences on this very important upcoming product and highlighting the intricacies and the challenges involved in preparing this radiopharmaceutical. I'm sure there'll be many questions from the audience. You can ask a few questions. Yes, please.
So my question is that when after you prepare the radiopharmaceutical, we release a product data sheet. Then whatever the amount of activity we are writing over there, so what is your opinion about that? Because many times we have done in a center, and by the time it reaches clinic, it says the value doesn't match, it is over that.
As I told, I am also nascent in actinium chemistry. So I had a lot of complications and confusions at the end of it. But I don't know what is the practice, what is being done. Mostly the practice will be whatever is activity which is quoted by the manufacturer. If he says 250 microcurie, believe the manufacturer, believe the vendor, and write it.
We also believe that way only.
But that is not the correct radiopharmacy practice.
Yeah, that's true. I agree with that.
Yeah, that's why I put this topic as intricacies, and I have selected this topic for me because I have confusions.
But at the end of the day, that we should bring about the translation between our HPG data to our much more easier instrument.
No, definitely we should quantify the activity what is being coming from there. And if you have an HPE and a good radiochemist there, he will be able to quantify it, because once you know what is the efficiency of those gammas in that particular energies, they will be able to do it. That is a very simple work for a radiochemist and not for a radiopharmacist. So that way, the amount of activity which is coming, we can quantify. There is no problem in it. The activity what is being injected, also I will say that take a small fraction of that, keep it as our batch control, and measure it after 4 hours or next day, and do the HPGE, then you will know how much is activity you have injected. So that's the only way which is coming in my mind. As I told, my experience in actinium chemistry is very little, but I am a radiochemist, and I was worried actually.
Same. As a chemist, you are telling that I am not sure, but sir, clinical results are very, very good. So what is your opinion on that? Because actinium-225 PSMA is giving very good output, sir.
Yeah, actinium, I used to put in my projections, actinium is a nuclear bomb, bomb inside the cell. You are able to give 27 MeV of energy from a very single decay. A single decay will give 27 MeV. And I am sure, our targeting agent PSMA is very good, dotatate is very good, and the radiopharmaceutical is very good. And once it is injected and it is being taken up by those cells, the cells will die. That is the reason why we give these excellent images what we see for actinium therapy. So I am not telling actinium therapy is not good. Actinium therapy will grow much, much faster once the actinium availability increases, and there are a lot of work which is going. But my point in telling here was that what practice we are doing, we should not be complacent and thinking that we are doing everything right. We should do it right. And it's not a criticism, because to understand the secular equilibrium, to understand the Stransian equilibrium, etc., it needs lot of experience. It's a wonderful isotope. I am not discounting it. Also, people say that, okay, actinium is injected to the patient. What happens to those francium? What happens to those things? Those other astatine? What happens? Definitely, ultimately, the clinician, what he looks is that whether the tumor density has come down. If the tumor density has come down, he doesn't care, or he is happy to tell that, I have treated my patient, and that is ultimate aim. But as a radiopharmacist, my aim or your aim is, whatever I am giving to him,
Yes, sir.
we should give the right product, and we should be sure about what we are giving to the patient.
Yes. Thank you, sir.
I just wanted to ask you, how are you sourcing actinium? Is it from a generator that you have in-house, or is it the radiochemical that you're
Actinium we have bought. As I told, we have done only one therapy, because the cost was too high. We could not afford further. So we bought it from one of the commercial sources.
Anyway, due to time constraint, I don't want to put forth the question to Usha that whether actinium-225 can be produced in the medical cyclotron in Calcutta. Anyway, that we can discuss later.
See, there is a beautiful nuclear reaction there. There is a beautiful cross section, very good cross section there, and there is a 30 MeV cyclotron sitting there. But a machine will not bring the isotope unless we work towards it. I am sure our colleagues will definitely work towards that. I am sure Usha is working towards that. So.